ready to start. There's enough people in here that we can get started. This is our general meeting, our third general meeting. It's going to be a VR/AR presentation. If you don't know what that means, then our presenters will go over that. But before we get into that, we have some announcements. So week 5, we have some events going on this week. I think everybody already knows about our Wednesday competitive programming series in the club room from 6 to 8 p.m. On Thursday, we have our, I think, 4th edition of the Career Readiness Workshop. And we're going to go over LinkedIn and GitHub, how to use these tools to get the attention of recruiters. And on Friday, we're going to have a social in the club room where we're going to be watching Imitation Game, which is a movie about Alan Turing and how he cracked the Enigma code. So I know we probably have a lot of midterms this week. So if you guys want to take a stress relief break or reward yourself for getting through the week, feel free to come out. And week 6, we don't have many events. There's still exams and stuff going on. We understand that. We're really busy too. But the highlight of next week is the Career Readiness Workshop series, where we're going to go over course plans. And if you haven't made an individual course plan yet, we're going to go over how to do that. We can tell you the best classes to take and stuff like that. And on Friday, we're going to have our first mentor-mentee day. And the matches will be released by the end of this week. So by next Friday, you'll know who your mentor or mentees are. And we're going to be going to the UV. So we're going to be meeting at the bell tower, and then we're going to walk to the UV together. And you guys can either treat your mentees or get free food from your mentor. And everybody should have access to the club room by now. The card system has been fixed. So if you still don't have access, then DM Divyank on Discord, and then he'll work that out with you. And match challenge, Vince, do you want to talk about that?
Yeah, sure. So, hey guys, right now we're in the last week of match challenge, and if you don't know what match challenge has been over this entire month, if you donate to ACM, for donations $25 and above, it gets matched by BCOE. It's been like a entire thing this entire month, but this is our last week. So please donate to ACM. It doesn't even matter if it's less than $25 because that's the stuff that gets matched. Just donations are really highly appreciated in general. And if you do donate, you get your name on the website forever, saying that you donated for this year during Match Challenge, and also you'll get a special role on Discord once Match Challenge is over. But we also have a final push kind of sponsorship committee type of thing. This is what one of my board members came up with. But if you want to put ACM sponsorship committee on your resume, if you sign that QR code, you can sign in and sign yourself up to being a part of the ACM sponsorship community. It's usually an entire process where you do you have to go to meetings and stuff like that. But really we just want to get you guys getting ACM's name out there. So sign up for that, and we'll let you know what to do after that. It's usually just sending 5 emails for people to get ACM on the board. But yeah, that's about it. Thank you.
So let's get on to the actual presentation. So this is going to be more of an informational kind of meeting about virtual reality or augmented reality and how that technology has evolved and stuff like that. And let's just get right into it. So here we have Professor Jiasi Chen. She is a research professor. She also teaches CS135 on campus, and her research specializations are in virtual reality, edge computing, and mobile computing, and all these other things that you can see here. And we also have James, who is a software engineer at Meta, and he's currently working on Horizon World, which is a part of the metaverse. And so, yeah. So, who wants to go first, actually? James, you there?
Sure. How do you want me to start this? How do you guys want me to start? You guys have questions for me, or how do you guys want to do this? Oh no, I don't have slides. I'm so busy work. So yeah, I can just go. I'll just do it. Yeah. So hi, I'm James. I did my undergrad here, and I graduated and finished in class of 2022. Also did my master's here, and I recently graduated in 2022, class of 22nd. And during my master's, I worked with Jiasi on AR computer networks and stuff. And doing research with her. Right now, I'm working at Meta as a software engineer, working on Horizon Worlds, which is like the VR metaverse project, if you would like to call it. And yeah, I guess that's how I can introduce myself.
Nice, nice. So, how were you involved in ACM beforehand? Can you hear me?
Yeah, I was an officer in ACM during my senior year of undergrad. I was pretty much in charge of a lot of the workshops. So during my senior year, I pretty much rewrote a lot of the workshops from scratch and led a few workshops, including iOS. Helped out with the Python workshop.
So, I wanted to ask you, so you mentioned before that you did undergraduate research. How would someone who is a first year or second year, how would they get involved in research?
Oh, I was just talking to Jiasi about asking her if she had anything that she needed help in her lab, and I just hopped on board during my undergrad. And that eventually led to me doing a research under her during my master's program.
How would you say your research experience helped you on your current career path?
Ooh, I would say like being able to understand some of the terminology actually helped a lot, because some of the stuff that I worked on with her, like I'm actually able to understand when we're throwing those terms around during our meetings and stuff. And understanding some of the situations that our team is currently facing is kind of like, hey, I kind of have an idea how to solve this issue just because I done something similar, and I can propose methods to potentially solve it.
Nice, nice. So what are some?
I don't want to go too in depth with the obviously.
I was just about to ask you a question, like is there like anything that you're able to talk about that you guys are working on, or like any new ways you guys are using VR or AR and stuff like that?
Yeah, I can honestly. Oh, for VR industries, like there's a lot I can talk about. Like I don't even know where to begin. Like I can honestly say that we're really focusing on like there's obviously so many sectors with just in the RL division. Like I'm part of the software division, which is in charge of building metaverse applications. There's also like the hardware division, which is like how do you shove like you saw the new Quest Pro, which is literally like a supercomputer in like a super small headset. Like I seen it, I played around with it. It's really amazing, and like that's another division that's like it's we're focusing on a lot recently. Like it's pretty much like that's from the hardware perspective of like shoving as much arm into like very small headsets, and also on the software side, like there is how do you build like effective AR applications? Because one of the things that people talk about is motion sickness, and if you take in CS135, which is like VR class, you won't really experience it firsthand, but it's still an issue that a lot of developers will face today. And even here, like we have hours and hours of conversation about how do we solve this problem, even from the software perspective, and whether that be our team like making some optimizations here and there, or other teams like developing methods to offset like how motion sickness and stuff. So that's something that's really interesting. Another thing is how to use what's quality over like performance. It's like, do we want to make the most realistic thing and have but at the same time what does it cost? like whether it be latency, which could also lead to motion sickness, or do you want the most realistic thing possible? So a lot of trade-offs in some of the research that's going on here, essentially. Otherwise, like most of the stuff that if you guys watch Connect conference, most of that stuff is what we're really working on right now. It's mainly the headsets and finding new ways to like connect people. And our company believes that VR and AR is going to be like the next big way people are connecting. Like there's already applications like Horizon Workrooms, which is like VR Zoom, which and like and if you guys are going to QE Hack, I'll be doing a workshop in VR for not on VR, but we're going to be using that software. So it's going to be a nice change of pace from using Zoom. So yeah.
Does anyone have any questions for James before we move on? No? Okay. So thank you, James. Round of applause for James. So now Professor Chen has prepared a presentation for us. It's about her own research. It's about augmented reality and virtual reality. So can everyone welcome Professor Chen up?
So do I control the slides from there?
Yeah.
Is there a clicker by any chance?
I can just click it for you.
Okay. I can do a few of them.
Okay.
All right. Hey everyone. So for those of you who don't know me, I'm Jiasi Chen. So I'm an associate professor in the department. I teach CS 135, which is virtual reality, and I also teach a graduate class, CS 204, which is advanced computer networks. I also run the ULA program, the undergrad learning assistance. So if you guys need help with your lower division classes, definitely visit our ULA free tutoring help. So that's like some of the things that you may have seen me around campus, but today I'm going to talk more about the research side of things, which is this whole hidden thing that is a whole big part of our professors' lives, but I feel like we don't get a chance to talk to you guys enough about. So I probably prepared about 10 or 15 minutes of slides, if that's okay, and it's just talking about some of the research projects I work on. So just hopefully give you guys an idea. I think it's going to be different than the kinds of aspects that James talked about, because James is doing more of the practical side of things, like the user-facing things, whereas research is a little more like under the hood and not as like pretty and fancy applications. Okay, so what's the motivation? So multimedia is central to our digital lives. So we might have started off with video applications, right, becoming very popular. And over time, we started having endless Zoom conference calls during the pandemic. And finally, we end up in the metaverse, in Horizon Workrooms, or whatever the metaverse is. So multimedia is just part of our, central part of our lives. So what are some of the problems that we currently face that we want to address in the research and development? So here's like a dream, which is, starting here. This is like a marketing ad, right? So here's an example of what they want you to see in Pokemon Go. And there's this nice digital avatar here. It's integrated really well with the real world. It looks beautiful, right? This is an advertising video. All right, so what's the reality? What can you actually build with current smartphone-based augmented reality tools? So this is an example from one of my students worked on. So you'll see on the left is a view of Alice and the view of Bob, and they're just trying to create some virtual characters and play it. So what you'll see is like nothing is really happening. There's no beautiful animations. It's just doing some initialization. Eventually, after a while, at some point, this guy finally pops up. And then finally on this side, again, we're waiting for a while. It's doing some initialization, have to type in some manual stuff. Okay, then it finally popped up, right? So there's a big contrast between what you will see in like a nice, beautiful marketing video and what you actually can do right now on current Android devices. Next. So the focus of my research is how can we make these network multimedia applications, including AR and VR, meet user experience requirements on especially mobile devices. So we have constrained battery. They have decent processors, but not as good as your like TPU or your like huge huge Colab or whatever. So focus on my research at the intersection of mobile computing multimedia, including AR and VR, and also mathematical optimization tools. And we typically have different kinds of trade-offs between accuracy, energy, and speed. And here are some example projects. I'm not going to go into detail because it's way too much, but these are some of the example performance trade-offs you might want to think about. So overall, my research is we do a lot of measurement and characterizations. So here we've done some measurements of AR performance on 4G LTE networks. We do a lot of modeling and optimization. So some of these algorithm skills that you're learning, like optimization or algorithms or dynamic programming, that can be useful under the hood. And then we also have system deployment. So we have in the lab HoloLens, Quest 2, Android devices, various things. And that's the sort of research methodology we use, right? So you might talk to different professors and they have different types of methodologies. Some professors are more practical and they just do more systems work. Some people do more theory, so mine is a bit of a blend of both. Okay, next slide.
Yeah.
So we'll go over this pretty fast because I think you've already known what AR and VR is. So on one end is VR, right? It's completely virtual. And on the other end of the spectrum is AR or even reality. So AR, you have some digital stuff here and some of the real world. So the two things are mixed together. And what I'll mostly be talking today is some AR things. Here are examples of AR. So we have like Magic Leap or the HoloLens. Those are really nice devices. And you also have the smartphone-based AR. So there are many cool AR applications. You can think of things on the battlefield or for education or for public safety. And living underneath those applications is the platform that supports these applications live on top. So mostly when you think of AR, VR, you'll probably think of these cool games or whatever you can build on top, right? But underneath that is this platform that provides the fundamental capabilities for any app you want to make. So for example, it could provide things like head tracking, understanding of the real world, interpreting hand gestures, right? These are all in the platform underneath. And then those all live on top of a bunch of hardware sensors and maybe also some infrastructure that helps. And my research is mainly on the platform itself. Okay? So there are people who work on making cool applications and they do fantastic work. My research happens to be more on the infrastructure or platform side of things. So this one, I think we will just skip it because it's probably too much detail, but this is more about how this was some research papers and stuff. I'll just show you some examples. So what are some problems that we see in current applications? So here is one about latency. Oh, actually, I haven't looked at this one. But yeah, let's start with this one. So here's one about accuracy. So suppose we have two users and they're trying to view the same Andy Android character. And you see they're kind of misplaced, right? In this user's view, the Andy is on the border of the paper, and in this user's view, the Andy is in the middle of the paper. So maybe it doesn't matter much for this application, but imagine you were playing like AR chess, right? If the chess piece is a little bit misplaced, hey, like where, it's gonna be a big problem. It's gonna be on the wrong square. So that's one example. And there's also another problem, which is latency. So suppose I move my virtual chess piece, and the person I'm playing with, you need to see when the virtual chess piece also moves. So when you measure latency, how long it takes on current devices, it could be quite long. So these are experiments we did it over public LTE, and it takes like 10 seconds from when one person places something to when the other person sees it, right? So imagine playing well, chess is probably okay, but imagine playing something more fast-paced and it takes 10 seconds for you to see the other users move. Not gonna be a good experience, right? Next slide. And then here's also an example of accuracy for a single user. So see how the marker is placed, but you see how it's kind of bouncing around back and forth, right? It should have been there, it's just kind of moving by itself. Right, this is measured on Android. This is measured on Android. So this is another example of the kind of accuracy problem we might see. We don't want to see those drifts. We want to see virtual stuff stuck in place where we place them, and they should move unless I want it to move. Okay. And another problem that we see is energy usage. So on the x-axis here is different types of applications, and the y-axis here is the power in watts per second. So if we compare these two pieces here, visual inertial localization and machine learning, are stuff that's really important in AR and VR. And they consume a lot of power compared to even watching a YouTube video on your smartphone. So imagine the future if everyone's gonna be using AR and running these types of functions in AR. it's going to drain your battery really quick. Just in personal experience, if you run like an AR app on your Android device for a while, it gets really hot, so it's also uncomfortable for the user. Okay, next slide. All right, so let me give you some examples now of some research projects that we worked on. I will tell you 2 short ones, and then I'll talk about the third one in more detail, which is all about AR security. So here's an example of, you saw that video where the thing was drifting around. So one problem we have is we want to quantify like how much is it drifting, right? We can visually kind of eyeball it, oh, it's drifting by a little bit, but how do we actually measure that? So it's not a very easy thing to do. So what one of my students worked on was quantifying that. So here what you'll see is this is a virtual thing. This is a virtual thing, and everything else is real. So this guy's like drifting back and forth across the paper, right? It's a very short clip, let me replay it. So the camera's moving a bit, but the object is also drifting. So what we developed was a tool that helps you quantify how much is that thing moving around. So on the x-axis here is time, and the y-axis here is the centimeters that the object drifted by. So we have made a way that you can automatically figure out, I'll give you a video recording of this, and you can automatically report to you how much was that thing moving around. Next slide. Another thing we worked on was, or we're currently working on, is considering AR/VR as a distributed system. So think of it this way: when you play an online game, like a multiplayer game, like some, I don't know, what's the popular online game now?
Like Overwatch or something like that.
Yeah, Overwatch, yeah. Okay, so they have a lot of techniques to hide latency from you, right? Because like you make a move, someone else makes a move, those things might conflict, and they resolve them somehow on the server. So we want to think about similar problems in AR and VR, right? Suppose I'm playing some AR game with you and you're remote, and what if we make conflicting actions? How do you resolve that? So there are differences in AR, so I'll just show you an example. So Alice is moving the cheese thing towards her, right? And then forget the rest, don't do that part. You just saw the first part, Alice moving the cheese in one direction, and then suppose Bob comes and is moving the cheese in another direction, right? And if those two things are happening simultaneously, which one is correct, right? Because the users now are going to have inconsistent views. So our idea there is to model the AR/VR system as a distributed system. There is a distributed systems class, I think, right? It's upper division, but yeah. So we want to apply those kind of techniques to AR/VR so that everyone can have a consistent view, even if users make like conflicting actions. Next slide. All right, and the last thing I want to, well, not last, but what I want to spend the last few minutes talking. That's all I kind of wanted. I don't want to drone on for too long. So in summary, I told you some stuff about AR/VR security issues, and also I showed you some issues with accuracy, latency, and energy. And just want to give you guys an idea of the different types of research projects I work on. That was like 5 research projects at once, okay? So obviously there's a lot more behind them. But just want to give you guys sort of a sampling of things. And click. One more click, or maybe 2 more. We are still running some studies. So we're always recruiting volunteers to participate in a short user study. We're still collecting data. So if you're interested in seeing experiencing one of these apps and being part of the user study, it would probably take about half an hour of your time. Please reach out, and you will get to experience these apps and also contribute to our research. So that's it. Thank you very much.
Does anyone have any questions or anything?
Yeah.
So when I was looking at most of your research, I was using a lot of Android phones.
Yeah.
Is that like a tie-in with the fact that Android is a little more open than
definitely.
than Apple?
Yeah.
So is it possible to do any of the same exact things on Apple software, or is it just?
We haven't done much with Apple, but when we look at the AR/VR platforms, it has a lot of the same APIs. So basically, I think that any attack that we did on Android or any research we do would also be similar in AR. We have done some AR kit on Apple measurements as well, so it should be doable. It's just like the results we think are going to be the same, so we just spend our time with Android. As you said, it's more open, it's easier to play with. We also are doing more on HoloLens, Microsoft HoloLens these days as well. But we start off with Android just because like people are more familiar with it. There's more like Stack Overflow responses, right? So it's easier to get started with Android. Yeah, great question.
Anyone else?
Yeah.
I feel like now the VR technically have been really different from what we imagined the ideal state of it. Is it more like the problem was hardware or software? Like right now in this state?
That's a really good question. I think there's both sides of things. I mean, obviously it's always like an arms race. Like the hardware is getting better and better. But I also kind of think that, like when I look at like the specs for like a Qualcomm AR/VR chip, and I'm like, what did they accelerate exactly? I feel like sometimes they don't know exactly what the computational bottlenecks are in AR and VR. So they'll be like, we do like TensorFlow TPU, right? But where are the tensors in AR/VR? Sometimes I feel there's a bit of a mismatch between the hardware and the software. But of course, better hardware also helps. Personally, I think it's more on the software and like having cool like killer apps is more of the issue. As well, like the security things that I talked about, people haven't like thought about that yet. So I think there's a lot, or they're only starting to think about it. So I think there's a lot more to go on the software side. Hardware, I feel, is more like when you know exactly what you want to compute, then you can accelerate it, right? But until you know exactly what you want to compute, I feel the software is more interesting, personally. But I'm also a software person, so I'm biased.
And I have another question. It's like right now, Meta Universe is like Facebook put a lot of efforts on it, but I feel like is it really impossible? I mean, is it really possible for everyone to use it? Because in order to use VR, you need hardware, you need like a lot of equipment, and I don't think everyone have the capability to buy it. So it's like, how can we solve this kind of problem to make VR open to everyone?
Yeah, that's a really good question. I mean, for a while they had those smartphone-based VR, right? Like the Google Cardboard and stuff, and the Daydream, but it kind of like, it wasn't that great, I think. So I think what they're doing now is they're making like the really good version, and hopefully they'll get enough people involved, and then eventually they'll like trickle back down to like the lower cost things. But as you said, I think, I totally agree with you, like accessibility is definitely a problem, but the lower cost ones just weren't that great. I think they already tried that, yeah. Yeah, but that's an important problem. Great questions.
Any other questions or?
Yeah.
How did you get started with your research?
So I used to work a lot on video, like video processing. So like how you would stream YouTube or stream Netflix and making sure the quality was good. So then I was like, okay, I'm tired of doing video, so I want to look at other cool forms of multimedia. So I just thought AR/VR was really cool. So I started spending more time on it. And yeah, just get interested in it and spend a lot of time understanding the background and learning about it. So that's how I got into it. Yeah.
If you want to like combine experience lab or check out any progression of how your research is going, is there any way that we can do that?
Yeah, you can send me an email. I don't usually have like open lab tours or anything like that, but if you send me an email or come by during office hours, I can tell you more about some of the projects or show you some of the hardware. Don't really have many demos going right now, mostly just like the videos I showed you, but yeah, if you stop by during my office hours, hours on my website, I'm happy to talk more about some of these projects. Yeah. Yeah.
I guess like what was like one of the biggest challenges you faced like during your research, like
Out of all of, sorry.
out of all of our research?
I would say it's kind of related to what you asked, like kind of getting into it, because my background is not in AR and VR. So it was really like trying to understand what was going on and learning all the stuff necessary so you feel you can make some like research contribution, right? There's a whole big community of like AR, VR, and human-computer interactions people. So it was trying to understand that body of work and also trying to put my own spin on it, which is coming more from like a networking background and having like the multi-user stuff. So kind of claiming your own space in this world.
If there's no other questions, then that's it for the meeting. Thank you again. So here's our socials. If you aren't already in the Discord, Slack, or follow our Instagram, here's our socials if you need them. Also check out our website here. Divyonk's not here right now, but he was responsible for making the website this summer, and it's really cool. And thank you all for coming. I think there's still pizza in the back. I hope there's still pizza. So if you haven't taken any, go take